Hello and welcome to Chapter 3, Numbers in the Real World. We're going to talk about Unit 3A, Uses and Abuses of Percentages. Okay, so there are three ways that we use percentages. We use them as fractions. Now, you might hear in a news report, a total of 13,000 newsroom employees, 2.6% of the newsroom workforce, lost their jobs. You might hear it to describe change. A company's stock fell 15% last week to $44.25. Yeah, I don't have a good newsroom voice, but Or we might use them for comparisons. The new battery lasts 175% longer than the older one, but costs 10% less. I might be able to do advertising, we'll see. All right, so let's look at a presidential survey as our first example. An opinion poll finds that 35% of 1,069 people surveyed said the president is doing a good job. How many said the president is doing a good job? Well, because the word of indicates multiplication, 35% of the 1,069 respondents is 35% of means multiplication in this case, 1,069. We think about things in terms of percentages, but we always do the calculations in decimals. It's percent. So this is like 35 cents, 0.35. So we'll take 0.35 times 1,069, put in our fancy little calculator, and we'll end up with $374.15. Now, we would say about 374 people said the president is doing a good job. We rounded this answer, this 0.15, we're talking about humans. So 374 whole humans said the president is doing a good job. It doesn't matter if from my right knee down, my leg thinks president's doing a good job. It's not a whole person, so we just exclude it. Absolute and relative change. The absolute change describes the actual increase or decrease from a reference value, a starting number, to a new value. So the absolute change is the new value minus the reference value. Now, the other one is the relative change, right? Absolute gives you a certain amount. Relative is going to be in a percentage, okay, always. So the relative change is a fraction that describes the size of the absolute change in comparison to the reference value. And even though it's a fraction, we always multiply by 100% to change this fraction into a percentage. So it's the new value minus the reference value, also known as absolute change, divided by the reference value. All right, let's look at some examples. During a 6-month period, Lunar Industries stock doubled in price from $7 to $14. What were the absolute and relative changes in the stock price? Now, the absolute change is the new value, 14, minus the reference value of $7. 14 minus 7 happens to be an absolute change of $7. That's the one that we can just kind of look at and see what's going on. The relative change will give us the percentage that it changed. So we'll take this same answer, really, the new value minus the reference value. 14 minus 7 is 7. $7 divided by $7 is 1. And 1 times 100% is 100%. This tells us that the absolute change in stock price was $7, which means an increase of 100% in price. You bought a new laptop computer 3 years ago for $1,000, and today it's just a doorstop. Today it's only worth $300. Describe the absolute and relative change in the laptop's value. So the reference value is the original price of $1,000. You bought it new for $1,000. The new value, right, the current value is $300. The absolute change is the new value, $300, minus the reference value of $1,000, which tells us we have a negative $700. That negative sign tells us that the computer's current worth is $700 less than you paid 3 years ago. Now the relative change, right, is our negative 700 divided by 1,000 times 100. It's a negative 70%. So the negative sign tells us that the laptop is worth 70% less than it was 3 years ago. Man, that's a bummer. I'm sitting here with a 3-year-old computer needing to change it out, and I hate feeling that loss. All right, so the absolute and relative difference. The absolute difference is the actual difference between the compared value and the reference value. All right, so when we're comparing two things, we'll find their differences. The relative difference describes the size of the absolute difference as a fraction of the reference value. All right, just like before, the relative difference is the absolute difference divided by our reference value and then multiplied by 100%. Examples. Recent data showed that California ranked first among the 50 states in average income at about $68,900 per person, and West Virginia ranked last at $46,600 per person. Now we're going to ask a question, same question essentially, in two different ways. How much lower is average income in West Virginia than in California? And how much higher is average income in California than in West Virginia? We're going to answer these both in absolute and relative terms, but notice here, than in California. So this is our reference. California is our reference here, and now for the second question, for B, West Virginia is going to be our reference. So it depends on which one we're referencing. So the absolute difference is the compared value minus the referenced value. And we asked about West Virginia, then compared to California. So we'll have West Virginia compared to California, and that's a difference of $22,300. So we take that minus $22,300. All right, the same value we'll get here, minus $22,300 divided by $68,900, and we'll end up with a minus 32.4%. All right, so we have the absolute difference, the difference in the incomes, and we have the percentage, the relative difference, how they compare to each other. The negative sign tells us the average income in West Virginia is less than that in California by $22,300, or by about 32.4%. For part B, now West Virginia is our reference. All right, so West Virginia follows than. So we use the West Virginia income as a reference value and the California as the compared. So we'll switch the order of subtraction. We know that these numbers are different by 22,300. One's going to be positive, one's going to be negative. California is more, so we know this is going to be positive. Now we'll compute the relative difference. We'll take this same 22,300, but notice we're dividing by something different now. Because we're dividing by a different divisor, our percentage will be different. It's actually a positive 47.9, but book publishers make errors too. That's the way it is. Average income in California is more than that in West Virginia, more because they're both positive, by $22,300, or about 47.9%. So Californians make 47.9% more than West Virginia, but West Virginians only make about 32% less than Californians. So it all depends on the reference value. All right. So we have this word of, right? Of means multiply. But then we also have more than and less than. And these are going to tell us slightly different things. If the new or compared value, well, more than and less than tell us the exact same thing. One's a plus, one's a minus. Of is slightly different. If the new or compared value is p% more than the reference value, it is 100 plus p% of the reference value. And we'll see a quick example of this next. If the new or compared value is p% less than the reference value, it is now 100 minus p% of the reference value. All right. Let's look. Jada earns 200% more than Reggie. What is Jada's income as a percentage of Reggie's? How many times as large as Reggie's income is Jada's? Well, we use the rule that Jada earns 200% more than, so we'll set P equal to 200. So we know our formula is 100 plus P%, which tells us that 100 plus 200% is 300%. Jada's income is 300% of Reggie's income. But because 300%, if we were to move the decimals two places, that's just 3. Jada earns 3 times as much as Reggie. All right, how about a sale off? A store is having a 25% off sale. How does an item's sale price compare to its original price? Well, the 25% off means that an item's sale price is 25% less than its original price. So we'll use our formula 100 minus P percent. If it's 25% off, P is 25, so we'll have 100 minus 25 in parentheses percent, which is 75% of the original price. That means if you originally saw a really expensive hat at the mall for $100 and it was 25% off, that means you could buy it for $75. Or you could take a walk to Fans and buy it for about $40. I'm just saying. Percentages of percentages. This is when the world kind of gets crazy. People do some bad things with this, so you have to be slow and careful. When a change or difference is expressed in percentage points, we're going to assume it's an absolute change or difference. But if we put the percent sign or the word percent, it's a relative change or difference. All right? So percent sign or the word percent, it's relative. But if we use the word percentage points, it's absolute. Okay, so if a bank increases its interest rate from 3% to 4%, the interest rate increased by 1 percentage point. That is an absolute change. It absolutely changed by 1 percentage point. The relative change, we'll have to use the formula. 4% minus 3% reference. So that's a 1% divided by a 3%. 1 divided by 3 is 0.33333 times 100 is going to give us 33% increase. All right, so relative to what the price was, how much did it change? Okay. Here's how we're going to solve percentage problems. If the compared value is P% more than the referenced value, then the compared value is 100 plus P% times the reference value. And the reference value is always, right, all we have to do is divide both sides by this 100 plus P%, and we can solve for reference value. If the compared value is a less than rather than more than, then we'll use the 100 minus P. So less than we'll use minus, more than we'll use addition. All right. You purchased a shirt with a labeled or pre-tax price of $21. The local sales tax rate is 6%. What is your final cost including tax? Well, your final cost would be the labeled price plus 6% of that labeled price. That's 100 plus 6% of the labeled price. 106%. Remember to change a percent to a decimal. We move the decimal 2 places. We'll get 1.06 times 21, which is $22.26. Now, this is how people mess up percentages. Shifting reference values. A 10% pay cut followed by a 10% pay raise does not take you back to the original. Doctor says, hey, decrease caloric intake by 150% to lose weight. This one drives me nuts. Oh, I'm out there on the field giving 110%. You can't. 100% is all. That's as much. That's whoop. Sure, something can increase by 150%. A price can increase, but we can't decrease by 150% because that's just not how it works. And we don't want to average percentages unless we're really sure the numbers involved. If 70% of the boys and 60% of the girls in the class voted to go to the water park, can we say 65% of the students in class voted to go to the water park? No, we can't. And let's look at some examples of these three and how they do not make sense. So a stockbroker offered the following defense to angry investors. I admit that the value of your investment fell by 60% during my first year on the job. This year, however, their value has increased by 75%, so you're now 15% ahead. But, let's see. Evaluate the stockbroker's defense. Imagine that you began with an investment of $1,000. During the first year, your investment lost 60% of its value, or $600, leaving you with $400. During the second year, your investment gained 75% of the $400 you had. So 75% of $400 is only $300. Therefore, at the end of the second year, we had the $400 plus $300, which is $700. Still less than the original investment of $1,000. Definitely not a gain of 15%. It's actually still a loss of 30%. What's the deal? Well, the loss of 60%, 60% of $1,000. But the gain was only 75% of 400. So that's the shifting reference values. All right, so watch your reference values each time. It's like the 10% pay cut, 10% raise. All right, now, a store advertises that it will take 150% off the price of all merchandise. What should happen when you go to the checkout to buy a $500 item? If the price were $100 off, the item would be free. So if the price is 150% off, the store should pay you half the item's cost, right? 50%, an extra 50% pass free. So that's half, or $250. Most likely, the store manager is needing some survey of math at DACC. That's what they need. Okay. In baseball, a player's batting average represents the percentage of at-bats in which he got a hit. For example, a batting average of 350, okay, and we read them like they're hundreds, but the decimal is important, means that a player got a hit 35% of the time. So how do we change to percentages? Move it twice, right? Suppose a player had a batting average of 200. I'm just going to put over here on the side 20% during the first half of the season, and 400 or 40% during the second half of the season. Can we conclude that his batting average for the entire season was 300? Well, 200 plus 400 is 600 divided by 2, 300. Seems like a good average. Why or why not give an example that illustrates your reasoning? Okay. The answer is no. Here's why. For example, suppose a player had 300 at-bats during the first half of the season and 200 at-bats during the second half of the season, for a total of 500 at-bats. His first half batting average of 200 means that he got hit in 20% of his 300 at-bats. 20% of 300, and if you want to put that 0 there so you can see the 20, that's fine. 20% of 300 is 60. His second half batting average of 400 means he got hits in 40% of his 200 at-bats, or 0.4 times 200, 80 hits. Now we had 60 hits here, 80 hits in the second half of the season. For the season, he had a total of 140 hits in his 500 at-bats, which gives us a 28%. Move the decimal. Oops, I moved the decimal the wrong way. There we go. To get 280. Not the 300 found by averaging his first half and the second half. The only way that he could have an average like that is if he had the exact same number of hits in each half of the season. At-bats and hits. All right, that's it for 3A. Thanks for listening.